Okay, everyone, thank you very much for coming to what happens to be the last talk of Teardown 2023. You made it. This is the final boss. There is no other castle. I do not have cake, but there is going to be a party afterwards. Thank you very much for deciding to be here. There's like a workshop happening, and I think there's like a discussion thing happening as well. But yeah, this is it. So, without further ado, this is my talk, A Piece of Raspi, the Issues and Implications of the Raspberry Pi. So first, we have a, whoop, that's not what I wanted. First, a brief disclaimer. This talk may contain chemicals known by the state of California to cause cancer, birth defects, or other reproductive harm. Just getting that out there. The real disclaimer. The views and opinions expressed in the following presentation are my own, and any resemblance to those held by past, current, future, or alternate timeline versions of my employers, affiliated institutions, spouses, or roommates is entirely coincidental. This is to say, this talk is my opinion. I'm not here to sell anything. Oh, I need to stop doing that. All trademarks are copyright their respective owners. The information presented here is not intended to incite, defame, or harass anyone. All information used is publicly available. So, first things first. This is not a talk about hardware hacking. This is also not a talk about open source hardware. This is a song about a whale. No, this is a talk about the Raspberry Pi. What it is, what it means, and how it shaped the world we live in, for better or for worse. So, as a brief outline here, we're going to cover some history, we're going to talk about some problems, we're going to go over some numbers, and then we're going to talk about some alternatives. So first, some history, or context for those uninitiated. In the early 1980s, the BBC launched their computer literacy project following a report produced in December of 1979 by the BBC's Continuing Education Television Department. So the report was called Microelectronics. And what they did was visit a number of countries, including the US, in order to cover the emerging technology of microelectronics. In their own words, in order to obtain a broad and non-parochial view of the way in which the new technology is being applied, and insofar as it is possible to judge what the likely implications might be for the shape of employment for the education and retraining services. The present aim is to make an informed decision about where limited resources should be used in the next few years in producing materials to help either special groups or the more general audience come to terms with this unpredictable but rapidly developing technology. So the first phase of the project started with the series, The Computer Program, aimed at educating and demystifying microcomputers and computing in general for the public. It launched with the accompanying computer called the BBC Micro, which was a 6502-based machine created by Acorn Computers Limited. There were two versions. The Model A variant was shipped with a 1.8 megahertz MOS 6502, 16 kilobytes of RAM, 4 video modes, and a basic interpreter. The Model B variant shipped with the same processor, but 32 kilobytes of RAM and 8 video modes. So, along with the same basic interpreter. I'm not sure I need to explain how important the BBC Micro was. It was a huge boon in the educational sector. The next machine developed by Acorn instead used a custom architecture called Acorn Reduced Instruction Set Machine, or Acorn Risk Machine, or later Advanced Risk Machine, or abbreviated as. So, it's kind of a big deal. So now we want to fast forward 30-ish years, 26, 25 years, something like that. So Eben Upton, during his time as the director of computer studies at the University of Cambridge, St. John's College, so sort of in charge of like admissions kind of, notices a decline in applications for computer science studies. And so in late November of 2008, him and some other colleagues start the Raspberry Pi Foundation with the purpose to further the advancement of education of adults and children, particularly in the field of computers, computer science, and related subjects. Or, as Eben Upton stated later in a quote when he received an honorary fellowship from St. John's, Raspberry Pi was originally conceived as a way to recruit undergraduate computer scientists, not just to the university, but specifically to the college. So this video on May 5th, 2011, by Raspberry Pi co-director David Braidman seems to say it all. I'm going to lean in here, and hopefully you'll be able to hear this.
David Braidman, what is this and what's it about?
Hi,
Right. This little device is a prototype version of a Raspberry Pi computer. It's a little tiny device that is a computer on a USB stick. It's got HDMI at one end, a USB at the other end, and the idea is you plug it into an HDMI TV, you can plug in a USB keyboard and use it as a computer to be able to learn programming, to be able to run Twitter, Facebook, whatever, but also to be able to understand the whole process of programming. A lot of things have been obfuscated in the sense that these days, in the sense that you can't get at them. There's so much between you and doing something interesting or creative that it gets in the way. And hopefully this device will be one of the pieces that helps change that.
The idea is that this would go into schools and would be cheap enough for almost every child to own. And then what would they do with it?
The idea is that they'd be 10 to 15 pounds, so that in theory they could be given away to the child. There would be other ways of funding it. What they would do with it is they would be able to engage in a lot of things that we're all consumers of, but not actually creators of. Understanding how you put together little scripts that might run on websites, that might filter, we all look at things like Facebook, like Twitter, also email, that a lot of kids are disconnected from. The wealthier kids in a class will have access to a computer at home. They'll have access to a mobile phone, but a lot of the kids won't. And this would hopefully fill that gap.
And you think that ICT in schools isn't really teaching them this kind of stuff at the moment?
In my day, we had a subject called typing, and that, to me, is what ICT has replaced. It's a fine set of skills. I'm not meaning to belittle it, but the ability to write letters, the ability to use PowerPoint, use Excel, is one set of skills. I'm talking about a completely different set of skills that actually ICT has ousted from schools. In the early days, in the 80s, we had computer science coming into schools. There were O-levels, there were A-levels. They've been largely supplanted by things like ICT. And the number of computer science applicants to universities dropped in the early 2000s by around 50%, which I think is a shocking indictment. And I personally put that down to ICT.
So how soon is this going to be in every child's hands?
It'll be a while for it to be in every child's hand, but we hope something will be rolled out within 12 months.
So the earliest capture of raspberrypi.org I can find is from the next day, May 6, 2011, where we can see an early prototype along with some specifications. There's a close-up. Fast forward a couple of months and we see another prototype in development with some physical boards appearing in August of 2011. Note the Broadcom logo, which is explained in the comments, by forum mod James Hughes. Broadcom are a partner to Raspberry Pi and are providing a lot of dev support in both hardware and software. Since the GPU is proprietary to Broadcom, the Raspberry Pi would not be possible without that support. It helps that Evan, the driving force behind the Raspberry Pi, is a chief architect of the video core GPU at Broadcom in Cambridge. The design goes through several prototypes before launching with two models. We have the Model A, which uses a Broadcom BCM2835 APU, which includes a 700 megahertz ARM 1176JZF-S core and a Broadcom Video Core 4. I think it was supposed to ship with 128, but they were able to bump it up to 256 megabytes of RAM before launch. DSI and CSI ribbon cable connectors there. Full-size SD card slot, USB port, HDMI, composite video out, and a 26-pin GPIO header. And then we have the Model B, which has all the same stuff, but with double the RAM, 256, later 512, an additional USB port, and 10100 networking. The A and B tier specification is not coincidental. It is directly patterned off the BBC Micro, and a lot of parallels can be drawn. The Raspberry Pi is clearly trying to fulfill the same spot in society as the BBC Micro, albeit 30 years later. But to summarize, after 6 years of development, we have a $25 to $35 ARM-based single-board computer with relatively low power consumption and competitive multimedia capabilities. Obviously, y'all know what happens next. It's a smashing success with the next 10 years bringing no less than 5 major board updates with newer and better processors, several iterations of smaller cost reduced versions, and several generations of system-on-module variants for embedded applications. As a quick but possibly incomplete rundown, we have The A+ and B+ variants of the OG board with even more USB ports, 40-pin GPIO and micro SD. The Pi 2 Model B with everything from the B+, but with a 900 MHz quad-core A7 and a full gig of RAM. The Pi 3 Model B now with a 1.2 GHz quad-core A53 and wireless networking, including Bluetooth. The Pi 3 Model B+ now with a 1.4 GHz 64-bit quad-core A53 CPU, gigabit NIC, and faster wireless networking, as well as a Model A variant. And the Pi 4 Model B, which is just like the last one, but with a 1.5 GHz quad-core A72, multiple RAM options, Bluetooth 5, USB 3.0, dual HDMI outputs, and USB-C. And we've also got the Pi Zero family, which is sort of like a first-gen Pi, but on even smaller boards, so fewer ports and clocked up to a gigahertz. The Zero wireless, now with Wi-Fi and Bluetooth. The Zero 2 wireless, now with a totally custom 1.1 gigahertz 64-bit quad-core A53. And the full line of compute modules, which is basically just the CPU, RAM, and storage on a little SODIMM module, comprising the compute module 1, based off of the Pi 1, the compute module 3, and 3 Plus, based off of the Pi 3, and the CM4, based off of the Pi 4, but now with integrated power management, optional networking, and a totally different form factor involving little Hyros connectors on the bottom. And also the Pi 400, a little keyboard with Pi 4 guts inside of it, a la C64. Pi Pico, an in-house microcontroller platform based off Raspi's very own RP2040, a microcontroller with MicroPython support. And I'm not even counting the myriad accessories like cameras, displays, and audio shields. Truly, what a time to be alive. But hardware is hard. And issues are inevitable, but you can learn a lot about an organization by how it reacts under stress. So now might be a good time to take a look at some of Raspi's hardware issues, more so to see how they handled them. Oh, by the way, I've given them all fun names to drive engagement. So a big part of the Raspberry Pi is the GPU, which has a multitude of hardware-accelerated features, which, as James Hughes explains in this blog post, are courtesy of some closed source libraries. We've got OpenGL ES 2.0 support, OpenVG, EGL, OpenMax, and then I believe through OpenMax we can use 2 hardware-accelerated video codecs, MPEG-4, the codec, not the container, and H.264, which you know what that is. A different moderator adds an additional aside to the post mentioning, the GPU can hardware decode H.264, MPEG-124, VC1, AVS, MJPEG at 1080p 30. It can do software accelerated stuff, blah, 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 whatever. We're restricted to the licensing for what we can turn on. So basically, it can do other stuff too, but we've only turned on like 2 of them. So does that mean that MPEG-2 video support is supported by hardware, but not turned on? Yes. Yes, it does. Now, for those of you not in the know, you need to remember that this is 2012, and MPEG-2 is what DVDs are encoded in. And people have been super interested in the beginning in using the Raspberry Pi as an HTPC. Like, you just go to the forum and just do a search for like HTPC, you know, sort ascending. And everybody just wants to hook it up to a television. And I mean, why would you want to hook it up to the television? I mean, presumably it's because everybody really desperately needs to play their totally legit, legally acquired rip copies of 1998's hit blockbuster, Twister, starring Helen Hunt and Bill Paxton. Okay? What are we gonna do? I mean, like, could we just like buy the licenses after the fact, like an extra like add-on for just the people who want them? I guess it could be an administrative nightmare, but it's not out of the question. Oh, hey, actually, Liz says, you know, it's totally something we'll check out. Liz Upton, by the way, is Evan Upton's wife. So they work on it. Hooray! Guess what? Codec licenses are available through the Raspberry Pi Foundation's official web store. Now that's really interesting, because if you know anything about how Raspberry Pis are sold, Raspberry Pi doesn't have an official web store. They sell through distributors. They have like a brick and mortar store in Cambridge, but they don't have a web store. They do have a web store. Let me show you what it looks like. That's all they sell. They used to sell stickers. At the very beginning, they sold stickers. But yeah, you type in the serial number of your Pi into a box, you give them some money, they email you a code that you put in config.txt. That's it. Next up. In 2015, forum user Peter Onion was photographing his Raspberry Pi 2 with a Xenon flash and noticed it would, like, power down. The forum launches into action with all manner of suppositions. OP suspects a poorly encased semiconductor as the culprit. Forum mod JDB gets right on it. He is able to replicate the issue with the Xenon flash, More people start experimenting with like putting blue tack over the SoC, but that doesn't help. JDB specifically suspects a particular wafer level chip scale package that's a power supply. More testing by forum users reveals a huge voltage spike on the 3.3 volt rail when you hit it with a xenon flash. So Liz Upton follows this up with a blog post talking about sort of the photovoltaic nature of silicon. This isn't a huge problem. It's only happening under specific circumstances. You could throw a little piece of tape over it if you want. It's more of like, oh, this is interesting. It's an interesting bug. We have an explanation for it. Moving on. The Pi 3B Plus launched with a kind of neat feature, the addition of a PoE header. Although I suppose you could say this is a bit of a misnomer because it's really just sort of a secondary 5-volt input that you plug in like a PoE voltage adapter shield on top of. That was released in August of 2018, but it had some problems. Raspi forum user Martin Rowan raises an issue on August 21st of 2018 about the USB ports on his Pi not working after being powered by the PoE hat. Immediately the forum springs to action because, of course, others have the same problem. People start testing various things. User The Raven really starts to dig in here. Good old James SH chimes in to say, hey, the engineers, look, we know about it, we're working on it. Here's where it gets good. Grazi kind of figures out a little bit of a workaround. He just sort of like moves the board off and connects it with wires, and that seems to help. The Raven keeps trying, adding in more stuff. And then Blaster delivers this diagnosis. My guess is that the problem lies in converter output voltage filtering, excessive noise disturbing overcurrent supervising features of USB controller producing false overcurrent messages. So basically, you get these little chips that sit on a USB voltage rail. It's like a circuit breaker. If the downstream device starts drawing too much current, it shuts off, it sends a flag to the SoC, hey, I'm overcurrent event, and you can go in and like reset them. So he's basically saying, hey, the voltage spike is like, the noise is triggering that thing. Some oscope readouts. And the Raven fixes it by adding more passives. Things start to get a little bit nasty with people talking about like RMAs, and this is a problem, and are we going to have to return these? And so there's some more like back and forth about that until finally James Hughes forwards us an email that Eben Upton sent to the register explaining the problem, which is just like Blaster said it was. It's an interaction between the fairly low frequency switching regulator on the hat and one of two brands of USB current limiting switches. So there's two different SKUs that they use on Pi boards, so only some of the Pis were affected. The large instantaneous current is fooling the switch into thinking that a genuine overcurrent event is occurring. We missed it in product testing because our heavy load testing was done on boards with the other brand of switch. Most of our field testers were only using the board to power mice and keyboards. Gory details. A significant portion of Pi hat pairs limited to delivering less than 200 milliamps of downstream current to USB. This is generally enough for mice and keyboards, not for hard drives. We're going to fix the problem in hardware rev. We're going to add a note about it. We're going to talk about mod options, adding some filtering. You can return it for a refund. The moral of the story, do more testing, particularly where you have multiple vendors for key bits of silicon. So forum post was updated by the OP. Here's the article from the register, and here's the accompanying blog post. Oscope pronounced, and this is the little mod, this is the aftermarket like mod board. So this is how they're going to fix the ones already in production. It's super neat. It's worth mentioning the OP, Martin Rowan, has a blog post talking about all this stuff, the issues. They sent him a mod board. He has a blog post about that. He ends with this. I, like the rest of the community, and no doubt the team at the Raspberry Pi Foundation, were disappointed that the issue made its way through internal testing and into production. The PoE hat was ultimately a very simple circuit in comparison to the Raspberry Pi, but getting power filtering wrong was a huge surprise. I wish the team had been a little bit more open and engaging with the community at the start, without the register needing to get involved to add some weight behind the investigations. I'm sure behind the scenes it was being actively investigating, but keeping the community in the dark about what was happening was a poor way of handling it. Hopefully all the issues are now in the past. I can now get on to the project I intended to use with the PoE hat. Moving on. Oh no, someone bought the rights for a low-budget sequel. You see, a few years later, Raspberry Pi comes out with a new PoE board. This time it supports the new higher-powered PoE Plus spec. So, ROP does a review of it as well. A wonderful in-depth thing, and he does a part. There are some problems with this one too. As a summary, there's some clearance issues with some of the screws and some of the standoffs. Large coil whine if you try and power it, like if you power it with like USB-C when the board's plugged in. Thermals, it runs very, very hot. It's shaped in such a way that the official case won't fit over it. So we have another summary here. I'm not convinced the Raspberry Pi team have fully embraced the feedback and lessons learned from the previous hat release. The new product doesn't appear to be sufficiently tested and doesn't look to have used the opportunity to utilize beta testers to cover scenarios in the environment the Raspberry Pi engineers might have overlooked. Unlike the original hat, the new Raspberry Pi PoE Plus hat does work, but there remain simple issues and more complex areas to investigate. Thermals of Raspberry Pi products seem to be an ongoing concern. This hat is no exception. This is compounded by claims in the release blog that runs cooler, which under basic tests have shown not to be true. Given time, I may go on to evaluate using this PoE Plus hat within an enclosure, as the increase in overall power usage and resultant heat might be a challenge for some enclosure designs. Finally, moving on. Tyler Ward, Raspi Forum user Scorpia, is looking over the Raspi schematic before his unit arrives and notices something weird. One of the CC resistors is missing on the USB-C port. Scorpia speculates this could cause, perhaps, issues with active cables or E-marked cables, and chargers actually smart enough to communicate with them. So think like a MacBook charger and like a MacBook USB-C cable. You see, per the USB-C alternate mode spec, with the low amount of resistance that they have on the board, the Raspberry Pi 4 could actually signal to like a smart enough charger to look for it that it's a passive USB-C audio adapter, and so it should receive no power. James Hughes is on it. He writes up a blog post talking about this. The forum thread continues. Yeah, people start testing it out, and yeah, sure enough, it's just like not working on some chargers. More people try, some of them have problems. Lots of theories. We go on to the next page. Eventually, James Hughes says, we're going to fix this in a board rev. Sure enough, we get an article in the Register. Eben Upton sent another email to the Register basically saying, yeah, the Pi 4 is not USB-C compliant. It'll get fixed eventually. Until then, use an official charger. Eventually, reporting indicates, the fix is out. We've seen new revs where they've moved some stuff around where it's clearly fixed. What I can't show you is a blog post from the Raspberry Pi Foundation talking about this problem, like with the last problems, because there wasn't a blog post about it. Moving on. Oh. Now we enter the modern era. Suffice to say, I'm not sure I need to explain what happened in 2020. Lots of bad things, the consequences of which we're still dealing with today. One of which was the chip shortage. In October of 2021, we see a blog post from Eben Upton about 40 nanometer silicon manufacturing allocations and declaring a temporary price increase of the Raspberry Pi 4 as a result of the chip shortage. What's particularly interesting, however, is this section about Pi 3B availability. In allocating our limited stocks of 40 nanometer silicon, we'll prioritize Compute Module 3, Compute Module 3 Plus, Raspberry Pi 3B, and deprioritize Raspberry Pi 3B Plus. Why is that? Users of the Compute Module will, of course, have made investments in carrier board designs and inventory. Raspberry Pi 3B has a single band radio without a shield can. Many industrial users will have made significant investments in compliance testing. The Pi 3B Plus uses the same chipset as the Raspberry Pi 4, which has an FCC modular certification, so you aren't going to need to recertify for it. So basically, if you're using a 3B Plus, please migrate to like the Pi 4 1 gigabyte. As a corporate user. This is interesting because it seems to be primarily focused towards placating their corporate customers. But it gets weirder. You see, a few months earlier, on April 4th of 2021, Jeff Geerling noticing a product announcement from Revolution Pi, a manufacturer of DIN-mountable pies for industrial applications. They have this new series coming out that's going to use something called the Compute Module 4S. What is the Compute Module 4S? Jeff Geerling doesn't know what the Compute Module 4S is. He writes a blog post about it. He goes to the forums. He's like, huh? This isn't on, like, Raspberry Pi's website. Like, what the heck's going on? And somebody tells him, oh, that's old news. We know about that. Also, there's another one that there's another compute module that uses the chipset from one of the Pi Zeros. So we go back to that original thread. Somebody notices a device tree source git commit for something called the 4S on Raspberry Pi's GitHub. Does anybody know anything about this? Total speculation, everybody's spitballing. People suggest, yeah, maybe it's like the new chip, but like on a SODIMM, which is right, but we didn't have any information at the time. One of the interesting things about this is how little any of the mods interact. I mean, there's a little bit back and forth about the pandemic and chip shortages and stuff, but anything about the 4S is left up to the imagination of the viewer. Eventually, the 4S does get a listing on the RPi website. There's no for sale link. They make it clear this is intended for industrial customers. Earlier, though, in that thread, somebody mentions RPTL. What's RPTL? Well, it's probably a good time to start talking about Raspberry Pi Trading Limited. Actually, Liz Upton explains the difference between the Raspberry Pi Foundation and Raspberry Pi Trading Limited when they actually split the website back in 2021. Basically, she explains that Raspberry Pi Trading Limited, now Raspberry Pi Limited, actually engineers, makes, and sells the Raspberry Pis, the accessories, stuff like that. And in a totally separate office building, Raspberry Pi Foundation does all of the charitable stuff, creating educational materials, training, teaching, sending out pies to people, stuff like that. One of the best ways to learn more about an organization is to look at its financial history, which, because it's a charity and a trading arm of a charity, is completely public information. So let's do that. Quick programming note, all the info I'm about to show you was collected by reading the last 10 years of financial reports from Raspi Foundation and associated companies. Also in 2021, Raspberry Pi Limited started to do their reports in USD. So they've restated 2020 figures in USD as well. But given the nested nature of it, some figures from Raspberry Pi Limited in 2021 are stated in Raspberry Foundation's financial reports, which still state everything in GBP. In cases where only USD figures are available, 2021 figures have been converted by me to GBP using the exchange rate from December 31st of 2021. So some weirdness there, but moving on. Okay, so we have turnover, which is, actually let's go back here. Turnover, which is essentially straight revenue before deducting costs. So you sell $1,035 Raspis, you have $3,500. That's your turnover. It's before deducting cost. We have our gross profit, our green bar here, which is after deducting cost, and then profit, which is the red, which is after like overhead and expenses. And then cash gift, which is the money that Raspberry Pi Limited gives to the foundation to do charitable stuff. So you can see sales really start to accelerate around 2016, 2017, and during COVID, stuff really just takes off. What's really interesting though is the turnover breakdown, which I'll get to in a second. You see Raspberry Pi Limited has several income streams, one of which is licensing, which is stated in the principal activities of their 2013 financial report. So back in 2012, most if not all Raspberry Pis aren't actually made by Raspberry Pi Limited. They're made under license by RS Components or Premier Farnell. And actually, since 2013, most Pis are actually manufactured by Sony's UK Technology Centre in Pencoed, Wales. They're a board house. Well, Sony factory in Pencoed, where Pis are built under license. And we have another post about that. So Their 2021 financial report also mentions revenue from direct sales to resellers, as well as characterizing publishing as their third income stream. So if you see a section labeled other, that's usually publishing. But wait, the 2020 report also talks something about components income. So let's explain how all this works. So essentially what happens is that RS Components and Farnell give money to Sony to make boards. They take those boards, they sell them, they give royalties to Raspberry Pi Limited. Now Raspberry Pi Limited also gives money to Sony to make boards, which they then take and sell directly to OEMs and resellers. But Raspberry Pi Limited is also a supplier of some of the chips used in Raspberry Pis. So when Raspberry Pi Limited gives chips to Sony that wind up in boards that get sold by RS Components and the other licensors, it's an actual sale of chips. But if Raspberry Pi Limited gives chips to Sony that get turned into boards, they get given back to Raspberry Pi Limited, it's repurchase liability. Apparently, they hadn't broken this out properly, which is why you don't see it in earlier reports, but it's broken out in 2020 and 2021. Now, we only have explicit breakdowns of turnover from 2015 onwards, but they paint a really interesting picture. So you can see the percentage of direct sales versus royalty sales starts to skyrocket. And then if we have the breakout of sales of components, and here we are for 2021. And this is restated, this is in USD, the proportions basically stay correct. Going back here. So if we want more of an explanation of why this all happened, we can head to the revenue section of the 2021 strategic report. So essentially, royalties, which is sales through the licensee channel, RS Components, Premier Farnell, increased because they were able to lower the component costs for the Pi 4s. So they're able to take a larger slice of that. And here we learn that the average revenue per SBC through the direct channel, so Raspberry Pi Limited selling boards directly to people, the average revenue per SBC increased because they sold more Pi 4 compute modules and fewer Pi Zeros. Accessory sales dropped due to lower sales of consumer SBCs. Consumer SBCs come with accessories. People bought fewer consumer SBCs, so people didn't buy accessories. We turn the page to the gross profit section where they talk about gross profit per SBC increasing due to lower component costs and increased sales to OEM customers. Compute Module 4s have less stuff on them, so they get more money per one that they sell, and the primary consumer of compute modules are OEMs. Here's a fun statistic called cash at hand. Look at that! So, so this is basically money left in Raspberry Pi Limited's back pocket after they've, all their profits and they've given away their cash gift. This is the little bit they have left over. So they built some up in 2019, they bought a bunch of stuff in 2020, and then 25 million pounds, which again, I'm converting, it's supposed to be like $35 million. Why is there a huge spike? Well, what if I told you it also had to do with that little cash gift right there in 2021, which was 3 million pounds? See, the funny thing is that Raspberry Pi Limited didn't give a cash gift to the Raspberry Pi Foundation in 2021. Well, they gave them a cash gift of £0. But they did give a cash gift of $4 million, about 3 million pounds, to Raspberry Pi Midco. What's Raspberry Pi Midco? Do they own Raspberry Pi Limited? Because it says they gave it to Midco so that Midco could give it to its parent, which is the foundation? What? To answer your question, yes. Raspberry Pi Midco is a holding company. As for the $34 million, well, it's a stock buy. What they did is they took shares of Raspberry Pi Limited, they cut them into pieces, and they sold them. And they were bought by Ezra Trust and Lansdowne Developed Markets. Ezra Trust is responsible for the $3.6 million bump in Raspberry Foundation restricted funds in 2021. So this is basically like the real money that Raspberry Pi Foundation has to work with. So the cash gift is money given to them by Raspberry Pi Limited, now Raspberry Pi Midco. Restricted funds are money given them to buy outside organizations to do specific things. And then unrestricted funds, it's money they can do whatever they want with. It's worth mentioning the cash gift is always part of the unrestricted funds pile. I'm just breaking it out here to show that, yeah, most of the actual spending money that Raspberry Pi Foundation gets is from their trading subsidiaries. Other interesting things we can learn include Liz Upton's salary. Again, the last 2 years converted to GBP, so there they are in USD. The average number of directors of Raspberry Pi Limited by year. And this is interesting. This is the total compensation for all directors for every year, and the compensation of the highest paid director since 2019. That's the years we have data for. And of course, coming up, we have the highest paid director's compensation as a percentage of the total director compensation. So in 2019, essentially the highest paid director was 47% of the total amount of money being given to all of the directors. This is, similar numbers in 2020. And then I'm restating this in GBP, but obviously this is the USD numbers for 2020 and the USD numbers for 2021. So it actually stops being 50%, it starts being 30%, but only because the pie gets a lot bigger. So it goes from 47% to 31%, but it still jumps by like about $200,000. So what do we know? Well, we know that Raspberry Pi Limited is trying to make computers as cheap as possible to give to kids so that they can become computer programmers. We know that Raspberry Pi Limited isn't perfect when it comes to interacting with the community. We know that Raspberry Pi Limited makes and spends lots of money. Raspberry Pi Limited pays its directors, at least some of them, very well. Raspberry Pi Limited is selling more computers directly than through licensors, and Raspberry Pi Limited is selling its computers directly to OEMs. Do you know what's also true? The Raspberry Pi is not open source. Now, technically, we have full or pretty full schematics for the first 2 revs of the original board. I'm talking like 2011 board. So here's what they look like. It's like 5 pages a piece. I don't think we have any CAD for it. I think this is basically it, but I mean, we can kind of see how the SoC is broken up. Those are the pads there, and here's the second rev. Just kind of paging through it. SD card, headphone jack, GPIO breakout, stuff like that, Ethernet hookup, not perfect, but a little bit reasonable. After this, we have these things called reduced schematics, which every other version of the Raspberry Pi, as far as I can tell, has. They're single page connector breakouts. There's no SoC on here. Look, the HDMI connector has HDMI signals on it. Fantastic. So this is the Pi 2 Model B, Pi 3A Model A+, 3 Model A+, again, Pi 3 Model B+, Pi 4. Is this a problem? Well, it's not a problem if you can get Pis. But if you can't get Pis, you also can't make your own Pis. And it's not just because of documentation. Remember, some of the parts are proprietary to Raspberry Pi Limited. Remember, Raspberry Pi Limited is a supplier of some of the chips used in the Raspberry Pis, like I think the application processor and the RAM, which sits on top in a POP configuration usually. You couldn't source all the necessary components to build a Pi if you had the documentation in order to build a Pi. The flow of Pis is dictated by Pi Limited. So why are Pis going to OEMs? Evan Upton has done a number of interviews recently with tech YouTubers like Jeff Geerling and David Bombal talking about the Raspberry Pi Limited response to the chip shortage. I wanted to play this one clip for you in particular. I believe this is around the 7:25 mark, on this video?
I'm just going to take on the role of some of the comments I've seen on YouTube, especially the hobby like sort of crowd, and they feel you're not looking after them perhaps because you're prioritizing like certain. I mean things have changed, haven't they? Because originally it was supposed to be for education, and then people who use it as a hobby got involved, and then it became more industrial. I hate to put you on the spot, but what would you say to them? You're not doing this on purpose, are you?
Nobody is doing this on purpose. This isn't a Raspberry Pi specific problem, but it is a problem, and I think I've said it's the hardest decision I've had to make in 12 years of running Raspberry Pi.
I've heard you say it's really painful for you.
It's incredibly painful, right? Because I'm a hobbyist, right? I mean, I'm in this for the hobby side. I'm not in this I'm not an OEM. I'm a hobbyist, right? I think what we got to remember is when we talk about OEMs, when we talk about industry, you're not talking about billion-dollar companies.
Yeah.
There are billion-dollar companies using Raspberry Pis deployed.
Oh, goodness.
They feel you're not looking after them perhaps because you're prioritizing like certain. I mean things have changed, haven't they? Because originally it was supposed to be for education, and then people who use it as a hobby got involved, and then it became more industrial. I hate to put you on the spot, but what would you say to them? You're not doing this on purpose, are you?
Nobody is doing this on purpose. This isn't a Raspberry Pi specific problem, but it is a problem, and I think I've said it's the hardest decision I've had to make in 12 years of running Raspberry Pi.
I've heard you say it's really painful for you.
It's incredibly painful, right? Because I'm a hobbyist, right? I mean, I'm in this for the hobby side. I'm not in this I'm not an OEM. I'm a hobbyist, right? I think what we got to remember is when we talk about OEMs, when we talk about industry, you're not talking about billion-dollar companies.
Yeah.
There are billion-dollar companies using Raspberry Pis, deploying Raspberry Pis at scale. We have a few of these kind of whales. People are buying hundreds of thousands of Raspberry Pis a year. But by and large, when we talk about, I've said we have 2,500, 3,000 OEMs. That kind of implies your average size of OEM customer is, on the order of 1,000 units a year. A lot of these are mom and pop organizations, small businesses. These are people who won't make the mortgage if they can't get Raspberry Pis. At the point where somebody has designed a Raspberry Pi into a product, there is a moral obligation to try to supply them with material. That balance, striking that balance between supplying OEMs, keeping OEMs alive, and supplying individuals. It's an incredibly difficult balance to strike. I think probably, one place where you see the consequence of us trying to make these decisions is in this sort of differential return to availability that you're seeing something like 0 or 3A Plus that doesn't have a substantial OEM footprint. Those are the devices that we see. So we're doing our best, and what our best looks like is bringing the products that don't have a substantial OEM footprint back into general consumer availability first, and then backfilling with a product like Raspberry Pi 4. Like Raspberry Pi 4 and compute module.
A moral obligation. What to do? The Raspberry Pi is a $35 single-board Linux computer. In an effort to chase that cost, they made a lot of sacrifices. But it didn't matter, because the point was to make a computer cheap enough to give to kids to program on. But there's a whole world of single-board computers out there. So BoardDB, which is the single-board computer database, is back online at hackerboards.com. We have filters for networking, RAM, composite video support, and a myriad of other outputs. You'll find stuff like the BeagleBone Green, which is a BeagleBone Black variant. So it's got a 1 gigahertz 32-bit ARM core, 1 USB, and 10100 Ethernet. It's $55 on Mouser right now. I checked yesterday, they had like 6,000 of them in stock. So it's more expensive than a Pi, and it's worse. Except it has tons of GPIO, both of those headers, all GPIO. And it also has 2 PRUs. A PRU, a programmable real-time unit, it's a little microcontroller on the die that you can drive directly through DMA. So what can you do with the PRU? Well, how about you drive 64 32 by 16, the 31 is a typo there, LED matrices with 0 load on the ARM core. So you can use the core for like image rendering. So that's 32,768 LEDs. which in other terms is a lot. It's a stinking lot of LEDs. So that's the BeagleBone in the center there. That board that all of these like off-the-shelf panels are plugged into, that board is passive. It's wires and conductors. There's no extra chips on that. It's just a breakout. Actually, I think there's because guess what? That breakout board is open source. There is a version of it that does have an RTC. But there's other BeagleBone type things, like there's the Pocket Beagle. It has this funky little package on here. This is a CSIP. It's basically the Sitara chip, which is the chip used in most of the BeagleBones. It's like a compute module, but in a huge BGA package. Guess where it also lives? On this board. You guys may have seen this board because it's in this CubeSat. And you may have seen this CubeSat because it's down the hallway. They use the PRUs to basically do all of like the, reading image sensors and stuff like that, all the silly, busy work and stuff like that. And they let the ARM core, which can run full Linux, and so they can run Python on top of it, do all of like the image processing stuff. Again, there was a talk earlier in the event about basically using every single piece of your microcontroller. Well, in this case, every single piece of your Linux computer includes 2 free microcontrollers. In conclusion, there's a whole world of options out there. Some are more expensive, slower, and harder to use. But it's also because they have more features, they use less power, and they're more complicated. They're not really worse options. They're different options. Not every problem needs a hammer. And when Raspberry Pi Limited has demonstrated through their finances, through their literal, actual, spoken out loud words, who they are prioritizing selling to, and it's not you as an individual, let me ask you this. Do you still want a Raspberry Pi? Any questions?
So I'm a fan of Eagle, but it sounds like you are too. The history is probably obvious, but just for thoroughness, I'll ask it. What did Eagle fail to do that Raspberry Pi did successfully? And more importantly, in the future, what can the Eagle Foundation and Eagle users do to change that?
So to restate the question in case the mic didn't get picked up, but gentleman who raised the question is a big fan of the BeagleBoard Foundation. It's a similar model to Raspberry Pi in the UK. They have some ties to Texas Instruments, but they're their own like non-profit thing. They make boards, stuff like that. And so the question was basically, what did the BeagleBoard Foundation fail to do that the Raspberry Pi Foundation did successfully? I would say it's cost, primarily. I mean, BeagleBoards they're more expensive. They are. Initially, the first BeagleBoard that came out was a bit, it was like $130, $140. It was based off the OMAP processors. The first BeagleBone, which is like the BeagleBone Green, it's shaped to fit in an Altoids tin. That came out in 2011. That was kind of neck and neck with the Pi, and it was a little bit better actually. It was a 1 gigahertz versus the 700 megahertz, or like an 800 megahertz instead of the 700 megahertz of the original Pi. I think one of the main reasons why BeagleBone has less penetration is because it's harder to use. And it's not harder to use because it's harder to use because like it's a single board Linux computer. Like there's not a whole lot of, there's some variation there in the weeds, but like, you run Linux, you can toggle GPIO, you can use GPIO libraries. There should be a lot of common ground here. It's more expensive. And so people bought fewer of them. The Raspberry Pi, it's cheap. The Raspberry Pi is cheap because it barely has anything. It doesn't have a power button. The original reason for that was they thought, look, this thing draws so little power, we can cut that corner. We don't need a power button. Maybe that was true 10 years ago. I'm not sure it's true now. But they were so aggressive in making it cheap that people bought tons of them. Bored engineers played with them, did all kinds of cool stuff with them, wrote tons of documentations and blog posts about them, took them into the work, and their boss said, what's that thing on your desk? And now they're in digital cinema projectors and industrial automation. You know, what a time to be alive. Yeah, it sucks. I really love the BeagleBoard Foundation. All the stuff's open source. They have a bunch of different varieties of things. You can build your own board that you want. You can do your own spin. It's great, but it's too expensive.